Hi everybody, this is a part 2 of this question. So we were looking at trying to figure out what the equation of this graph was for an exponential function. And now I'm going to be looking at the second part of this. So we did come up with an equation that f of x is equal to 0.5 times 3 to the x power. So now based off of this information that we have here, we do notice that the y values are in 10,000s. So these numbers obviously are adjusted accordingly. We are asked to find out what the population will be when we reach 1 million. So we could use this equation right here and do a little guess and check work if we wanted to, but I'm going to show you how to do this a little bit more efficiently. So we're going to start off with f of x, rewriting this equation. So 0.5 times 3 to the x power. So when we're trying to undo what we have here in order to, we have the answer, the output, the f of x value. We're trying to figure out the exponent, which is x. When we're looking at this, we have to think about inverse operations. So a lot of times when you do, solving equations for x or whatever variable it is that you're looking for, we've gotten through a lot of the easier stuff. Now we're going to start getting into a little bit more challenging things. We are going to replace this f of x. Now it is in 10,000s. So if we're reaching 1 million, we want 100 to be the number, because 100 times 10,000 will get me the 1 million that we're looking for. So we're going to start with that. So replacing this with 100, because again, that times this would be 1 million. Now this is not going to be, it's not going to be exactly the number that we're looking for. So it's going to be an approximation. Now we have this, we want to start to think about how to undo all these things around the x. So the first thing I'm going to do is, this is a multiplication right here. So I am going to do a division to get rid of that 0.5. And when I do 0.5, that will cancel that out. This is going to leave me with the 3x that I have, 3 to the x power. And then when I do 100 divided by 0.5, we end up with 200. So now we're left with this. So again, this is just calculator, nothing crazy, and not doing anything fun or fancy. But now what I gotta do is get rid of this 3 that's the base of this exponent x. So in order for me to get rid of that, I'm gonna do the opposite operation. So we're gonna do log of 3. So this is for undoing exponents, to get the x that is the exponent alone. And then what we're gonna do is we're gonna do log here. So again, we can't just do one thing to one, I got to do it to everything. So we're going to take the log of 200, which is our current answer, and we're going to divide by the log of 3 here. And then when we do that, that's going to cancel that out, leaving me with now the x is going to become a number that we're looking for. And we're just going to do this. And on my calculator, we're going to do log, and we're doing this, you're going to do log, and then you have a parentheses that starts it, and you're going to do 200 because that was the number that we started with right here. And then I'm going to close the parentheses because you got to make sure you do that. Then we're going to do divided by, and then we're going to do log again. And this time we're going to put 3 in here. And then we're going to close that parentheses, and then we're going to hit enter, and we get an answer of approximately 4.8-ish. So it's somewhere between 4 and 5. So it's 4.8 would be acceptable for an answer to get. And again, if I really wanted to, I could have sat and guessed and checked and plugged in various numbers for x as the exponent to figure out the answer. And I would have gotten, if I'd plugged in 3 to the 4th power, I would have ended up with 81. Which would have been 81,000. And then if I had done 5, I would have ended up with, as 5 as the exponent, I would have ended up with 243, which would have been 2,430,000. So that would be too much. So it's somewhere in between, obviously closer to 5. But that's how you would go ahead and solve a question like this when you have an output and you're trying to find the input value for an exponential function. If you want more questions like these, you can find them on my YouTube channel, Instagram, and TikTok at YouWantAlgebra. All of them can be located and much more in my exponential functions playlist. And don't forget to like, share, follow for more.